What's up? What's up? What's up? It's your boy, the network. And today's topic is configure and verify RIP version 2 or RIP version 2. This is a topic in the CCNP ROUTE Exam, exam code 300-101, version 2.0. Let's take a look at the exam blueprint and see where we came from, where we're headed. This is the implementing Cisco IP routing, also known as the CCNP ROUTE Exam. We just wrapped up the route poisoning section, which was section 3.15c. Today we are going to be configuring and verifying RIP version 2. This is an older routing protocol, but it is still, however, on the CCNP ROUTE Exam because this is a basic routing protocol that we just need to know. After that, we are going to be configuring its successor, which is RIPNG, or next generation. We notice the keyword, describe. We only got to describe it. RIP version 2, we got to configure and verify. So what is RIP version 2? RIP obviously is the second version of version 1, RIP, routing information protocol. So routing information protocol is a routing protocol just like OSPF, BGP, EIGRP. It's just an older routing protocol. Maybe I can pull up some fun facts. I believe it was developed in like the 1980s, sometime in the early 1980s. So remember, these routing protocols are what routers use to share different routes to get to different networks, right? RIP is one of the earliest routing protocols there is that's out there. It's still used today. Like I said, I work for a managed service provider. I have yet to touch a network that is still using RIP. It wasn't really very secure. And not only that, it didn't scale well. They did come out with version 2, and then now there's next generation, which supports IPv6, etc. We'll discuss what's the difference between version 2 and version 1. So again, simply put, it's a routing protocol. It's the second version of RIP, basically. So let's go ahead and head over to the slides, take a look at the official definition and some more material. Okay, RIP stands for Routing Information Protocol, if you haven't learned by now. I got my backup phone here. I couldn't find my other phone. It's somewhere, and it's like 2 in the morning right now, and I don't feel like waking up my girlfriend and stuff to look for the damn phone. But anyways, routing information protocol is a commonly used. I have yet to see it. If you are a network engineer or network technician or in the field, in the IT field, and you touch an RIP network, please put a comment below in this video. I have yet to see any network that is still using this routing protocol. Please comment. If it's RIPNG, then so be it. But even that, let me know. Commonly used in routing protocol in the small to medium TCP IP networks. It is a stable protocol that uses distance vector algorithm to calculate routes, right? What's distance vector? That means it goes by the direction, right? But it uses hops as a metric. Whereas EIGRP uses bandwidth and delay. OSPF, I should know that by heart, shouldn't I? I don't know. I'll put it in the comments below, in the description below. I can't remember. I can't think of it off my head. But anyways, that's routing. That's a basic definition for routing information protocol. Here are the differences between version 1 and version 2. Right? You can pause this, freeze frame it. I'm not gonna read all of this to y'all, but let's go. Actually, let's go ahead step by step, one by one, and then we're gonna do a quick hands-on on. Not GNS3, but Boson Net Simulator. You know, I try to mix it up with these labs now. But anyways, version 1 is distance vector. RIP version 2 is a hybrid, meaning it's a bit of distance vector, and it's also a little bit of link state, I believe. So it uses a little bit of link state. I don't know. I gotta research that. They are both used for medium-sized networks. Nearly all routers support both version 1 and 2. The periodic updates, I've said this multiple times in the last video, the updates come every 30 seconds. You would think that sounds like, oh wow, updates every 30 seconds. That's not very frequent. EIGRP sends, by default, I believe it's like every 3 seconds. Yeah, every 3 seconds. And you can change that, obviously. You got to think about when RIP came out. This was back when, if the network went down for 30 seconds, it wouldn't be that big of a deal. Nowadays, your network's down for like 2 seconds. You're like, hey, is your email up? People, you start seeing heads pop out of their cubicles. You know, in my house, my girlfriend will be like, hey, what's going on with the internet? I can't watch Netflix or whatever. You'll know when the internet is down. So 30 seconds is a little too long. But anyways, both version 1 and version 2 does 30-second periodic updates. Version 1 does not do triggered updates. Version 2 does. I'm not going to read all this to y'all. The main differences is version 1 does periodic updates using the broadcast address, which is 255.255.255.255, whereas version 2 uses 224.0.0.9, which is a multicast address. It does not broadcast its updates, it multicasts its updates. So it means it selects, you know, how you configure it. It selects which routers should get these updates. Yeah, like I said, I'm not gonna read all this to y'all, but anyways, version 1 is class full. Version 2 is classless, meaning you could do subnets, whereas version 1 does not. And yeah, I'm not, like I said, y'all can read most of everything else is the same. It's faster than version 1. That's it. So pause this, freeze frame it if you want. Okay, so these are just the basic configuration steps. You just go to global config mode. You do router RIP, just like BGP or OSPF. You do router and then the routing protocol. So in this case, RIP. You got to type in version 2 because by default, if you just go into RIP mode, you'll be in version 1. So you actually have to type in version 2 to be using version 2. And we've talked about what the differences are between version 1 on the left-hand side and version 2 is on the right-hand side, right? Then you just type in your network statements, pretty similar to OSPF, BGP, and OSPF, and then you do no auto summary. The thing is, you don't really have to do it does not have do wildcard masks. It is a class full. Version 1 is class full. Version 2 is classless. So you could, I don't know. I don't think you got to do wildcard masks. I don't think you could do wildcard masks with version 2. I'm not too sure. I got to double check that. Verification is pretty much the same as the other routing protocol, show IP route, show IP RIP database. It's not very much. You could just do a debug so you can see the periodic updates and show IP protocols. And let's go ahead and get our hands dirty with Boson Netsim and do a quick little configuration and verification of RIP. Yeah, let's try to stay awake this late. Lab every day. All right, so this is going to be the lab that we're working with today. It's a supplemental lab in Boson Netsim. This is the older version. I believe it's version 10. Can't remember. But anyways, this is the objective. We're going to practice configuring RIP version 1 and version 2 and learn about the differences between RIP version 1 and version 2. Here's our topology right here. We got router 1 with a Ethernet connection to router 2. He's got a serial connection to router 3, and router 3 has a serial connection to router 4. We're going to be configuring RIP between all these guys, right? These are the basic commands that we are going to be using. You should probably know these by now. This is a real like refresher to be honest with you. I don't know why it's on the CCNP exam, but you know, this seems more of a refresher topic. Here goes a couple more commands right here. Show IP protocol, show IP route, and version 2. Like I said, it enables version 2. These are the IP addresses we're going to be working with. Here's our tasks. Router 1, configure RIP version 1 to advertise the subnets currently configured on the router interfaces. So I believe these interfaces have already been configured. Thank God, because the other lab, you had to do all the housekeeping at first on the router interface. Okay, so should the first network statement specify 160.10.0.0 or 160.10.1.0 and why? So let's see. Router 1, we got two interfaces in the 160.10 network. So the serial interface is 175 network, 175.10 network, right? These two are in the 160. So that tells us, if you know about subnetting, we need to be using this as a network statement, right? In our network statement, because the subnet mask is /24, right? But these are different octets, 1 and 2. So that means we are going to just be concerned with the first 2 octets because we know the other ones may be different. So we're going to use our network statement to have specified that. If we just do 16.10.1.0, then we're not going to include the 2.0, which is why we need to do 160.10. That is why. So configure RIP to advertise that network right there. So let's go to router 1. Where is it? That's that bad boy right there. And we are going to go, the password I believe is Cisco. enable mode, and privileged exec mode. And then we're going to go into, I believe it's Cisco again. And now we are going to go to global config mode, terminal. Man, it's too, I don't know why they got passwords on the damn application. All right, so we need to go, remember it is router RIP. We're not going to do version 2 yet. So it says here version 1. So that means it's on by default, like I said before, right? We're going to do network 160.10.0.0, I believe it was. Yeah, 10.0.0. And that's it. And that's pretty much it. Router, that's the basic configuration for RIP. Let's move along. On router 2, configure RIP to advertise a subnet on the fast Ethernet 00 interface. So router 2, we need to specify this network. So we'll go on router 2, do the same thing. Enable global config mode, router RIP, network, I believe 160.10.0.0. We could do 1.0 on this because there's only one interface, but we'll do 0.0. Actually, you know what? Let's be more specific because it says subnet. So let's get rid of that. Control A, no. And then we're gonna do network 160.10.1.0, right? We'll do that. All right. On router 3, configure RIP version 1 to advertise the subnet on serial 00 and serial 001 or 01 and fast Ethernet 01 interfaces. So we got to go to router 3 and do router RIP for each of these guys. Let's do, we're going to do /24. So we're going to do up to the 3rd octet, right? So let's go to router 3, which is that guy right there. Enable, we're going to go to privileged exec mode, password is Cisco. That's so much for security, right? Configure, we're going to global config mode, interface, I'm sorry, what am I doing? Router RIP, and we're going to do 175.10.10. So we're going to do network 175.10.1.0, network. The other one is 180.10.1.0. The other one is network 197.10.1.0. And let's see what we got so far. Let's do some show commands here. Do show IP route. You see, we got the 175.10. These are the we haven't learned any RIP networks yet. These are all connected networks, right? So let's do a show IP protocols. Make sure we're doing that correctly, and we are routing for those networks right there, right? I guess I didn't do 1.0 there, did I? Probably because, you know why? This is the reason why, because that's why that is why. See, version 1, notice how I put 1.0 for the first network statement. I'll show y'all. I did 10.1.0, 10.1.0. I did 10.1.0 for all these other ones, but then it automatically summarized the first two. That is what, let's do show IP protocols again. That is what RIP does. It may or may not be a good thing. For the most part, you don't want to you don't really want to auto summarize because you're going to be working with subnets. So we didn't want that to happen, but they did that on purpose. So that way you can see the difference between RIP version 1 and RIP version 2. All right, what's the next thing we got to do here? So we configured RIP to advertise on these subnets on router 3. We got to do the same thing on router 4 actually. 180.10.1 network and 192.168.1 network, right? So we're gonna go router 4. Remember, we basically doing some basic configuration here. We doing some basic subnetting. Y'all should know. Y'all should kind of know that stuff by now. I'm not gonna go over the basics. Maybe I'll do some CCNA and CCNT videos in the future. So we're gonna go to serial 0, 0 interface. I'm sorry, router RIP network, and we're gonna do that network 180.10.10, 10.1.0, and then the other network, which is this one right here, 192.168.1.0 network, 192.168.1.0 network, right? Let's do a show IP protocols to see what happened if we do show IP protocols, and he's saying RIP is summarizing for, routing for that network, and then for the other one, that was summarized. Notice I put in 180.10.1.0, but then it summarized it and said, hey, this is the 180.10.0.0 network, right? This is a limitation with router RIP version 1. That's what I believe is happening here. All right, so the next thing we got to do here, on router 1, display the dynamic routing protocols that are running on the router. How frequently does RIP advertise routing updates? We did that in the other one. So let's go to router 1 and talk about what, or show what is being ran on here. When you show IP protocols, how many seconds? Right there, it says it. I said it in the last video too. Sending updates every 30 seconds. Next update due in 29 seconds. Right? That is what it is. That's the answer. What is the hold down interval for RIP? The hold down interval is right there. Hold down 180. So that means if it hasn't heard from any a specific, RIP neighbor in 180 seconds, it will consider it dead and remove it from its route. Correct me if I'm wrong. I'll double check though, but I believe that's what the hold down timer is. I'm over here talking about basics, and I don't even remember the hold down timer, right? All right, so allow the network a few minutes to converge. A few minutes. You see, this is the reason. This is another limitation with RIP. You have to have a few minutes for the network to converge. You know what convergence is, right? That's when all the routers know about all the routes and knows how to get everywhere. That's when you consider a network converged. On router 4, display. I think we've done a couple minutes. I've been talking y'all ear off. I've been yapping y'all ear off.
Shut the hell up! Damn!
On router 4, display the routing table. Let's do that. So router 4, do show IP routes, and look, he's learned two RIP routes and also his connected routes, right? So router 4, he's got his serial interface there. On router 4, display how many directly connected routes are there, and how many remote routes are there. This is a directly connected route, 1, 2, and these are the 2 remote routes. These are the remote routes, 1, 2. This is how you know it's a remote route, right? When you see that's a different, when it's been learned from a different routing protocol, right? And also, this is how I do it. I used to have issues with, problems looking at these routing tables. Whenever you see these brackets right here, and then a via, that means you know he learned that information from somebody else. When it's directly connected, this is either an interface or a loopback, a physical interface or a loopback on our local router. That means these networks we should know about it because they're directly connected to us. And then they are subnetted by this address right here. So these are remote routes. These are local routes right here. So local, directly connected, and remote, meaning he learned it from somebody else. What is the administrative distance for RIP? 120. We've discussed that in the slides, right? We did, but unless you didn't freeze frame it, you might have missed it. But the administrative distance for both version 1 and version 2, it's 120. On router 4, ping router 1 and router 2, these pings should succeed if RIP is configured correctly on all routers. Let's double check. So let's go to router 4. If we already on there. So let's go to privilege exec mode and ping 175.10.1.1, right? This guy right here. 175.10.1.1. And we did not get a reply. So we did something wrong here. It was not configured correctly. So let's see why. 175, it's not configured correctly because we have 175.10.00. So we need to fix that network statement there. What do we got here? We didn't do that on router 4? Let's double check. On router 4, ping router 1. Router 4, I guess we didn't. Why didn't we do that? Interesting. Can we ping router 2? Let's see if we can ping router 2. Because we didn't get a reply on that one. Ping 160.10.1.2. 160.10.1.2. No replies. Okay, said the ping should succeed if we configured it correctly. So obviously we didn't configure them correctly. Let's go to router 4 and figure out this problem here. Router 4. We are routing for those networks. 180.10.1.0. That's really interesting. That means, okay, I believe those are correct. So let's go to router 1 and fix this guy. Let's fix that guy right there. Let's do 175.10.1.1. So we're gonna go to router 1 and fix that. I guess we didn't do that. We only did one network statement there. That's the problem. That's the problem. We didn't do those network statements. Router RIP, configure terminal router RIP network 160.10.1.0. We did that, right? Yeah, we are doing that. So we got to do 175.10.1.0, 175.10.1.0, and network. Yeah, we did that one. That should be good enough for that guy. And now let's see if router 4 can ping that first one. Still no reply. We got to do 175.10.0.0. No, that's the reason. That's it right there. Something's wrong here. Are these interfaces up? Should be up. Go back to router 4. Router 1. Let's see if we can fix that network statement. Do show IP protocols. 170.10.0. Says it should have been maybe we didn't allow it to converge. We gotta wait till the 170.10. Oh, maybe that's the reason. We gotta wait till the network converge. I don't know, but we gotta reply that time. Let's see, 175.10. Okay, so that was the first one, 175.10.1.1, and the next one was 160.10.1.2. Ping 160.10.1.2. We got to reply that time. I don't know. Maybe I just didn't give it time to converge because I really didn't do any. I was missing one network statement, but the other one should have pinged. I don't know what I did wrong there. But anyways, we got that to reply. Task 2, review the limitations of router RIP version 1 and configure version 2. What are the class boundaries for IPv4? You know what the class boundaries are? We got class A, which is, I believe, the one network all the way to 127.0. 127.127, and then class B, which is 128 through 191, and 128 through 191, and class C is 192 all the way to like 224, something like that. Those are the class boundaries. By default, is RIP a class full or classless routing protocol? We'll look at the slides and I'll tell you. It's class full. I needed to answer that. It's full. It's class full. That's version 1. Class list, version 2. Remember, class list means you could subnet and do variable length subnet masking. Router 1, create a loopback 0 interface and assign it this address. This is basic housekeeping right here. Let's go to router 1. Where's that guy right there? And he wants us to create a loopback 0 interface and give it the address 160.10.2.1. IP address 160.10.2.1. And the subnet mask is /24 255.255.255.0. Allow time for the network to converge. And then view, we're going to give it some time this time. And then view the routing table on router 2. Do you see a route from router 2 to router 1's loopback 0 interface? I believe it's not going to come through because we didn't put version 2. So let's go ahead and give it some time to converge. We did that. I'll pause it and fast forward. All right. I think we back. Let's go ahead and view the router table on router 2. Here's router 2. Do show IP route. And we have all these interfaces, right? He learned all this stuff from another router. He learned that from another router. This is directly connected to us, right? That's from router 2, right? So this is directly connected to us. That's the one that's directly connected. That network right there, 160.10.1.0, and everything else was learned remotely. All this stuff was from somebody else. So he says to view the routing table. Do you see a route from router 2 to router 1's loopback interface? So router 1's loopback interface was the one we just configured, 160.10.2.1, which is, we see networks for, we see that right there, 160.10.0.0. We don't see the 2.1, so that's probably because we're still using RIP version 1. So I don't see that yet. Let's check one more time though. Do show IP route. It's not in there, right? It's not in there. So on router 2, attempt to ping that address 160.10.2.1, right? So ping. Let's get out of that. Ping 160.10.2.1. I don't think we're gonna get a reply because it's not. We are summarizing. We're still using RIP version 1. I believe that's the reason why. What is the benefit of using RIP version 2? For this reason why, because we can't ping the 160.10.2.1 network because it's a class. This would be a it's actually class full because it's /24. But we are doing /16 in this case, right? Because we only see 160.10.0.0. So that's really /16, not /24, which is a class full address. So I don't know why it should have went. But anyways, it fails. What is the benefit of using RIP version 2? Well, it converges faster. You can do variable length subnet masking. You could do class list addresses, class list addresses. So on router 1, 2, 3, and 4, configure version 2. Let's do that. So on router 1, let's go to router 1. How do we do that? We go to get exit out of this and router rip. This is how you configure version 2. It's a real hard command. It's really hard. Version 2. Look at that. Let's go to router 2. Configure terminal, router rip, version 2. Same thing with router 3. We are already in routing config mode and do just version 2. And then router 4, we do the same thing. Global config mode, router rip, version 2. When you configured version 2 in the previous step, why was it unnecessary to issue the commands to advertise networks? Well, we already did that before. Router 2, attempt to ping router 1's loopback interface. Now we're going to try to do the same thing we tried to do before in the other step, this one right here. So on router 2, We're gonna try to ping that guy once again. Where's that one? Ping 160.10.2.1. And we got to reply that time. Why? Because we can actually see that network now. I could show y'all. Do show IP route. Now we can see the 172 or 160.10.2.0 network. When we couldn't see it before. This is how our routing table looked like before. We didn't see the 2.0 network. We only saw the 1.0 network. We did version 2, and now we can see the 2.0 network. Y'all see that? All right, so does it fail or succeed? It succeeded. On router 2, I believe we only got 2 more steps, and then we're done, right? Step 10, 11, and 12. View the routing table. You should see now we did that. You should now see a route for the 2.0 network, which is the network in which the IP address for the Loopback 0 interface on router 1 is configured. We did that. Why is it necessary to wait a short period of time after enabling RIP version 2 on routers before you verify connectivity by issuing the ping command? Just like we had the issues with earlier in the earlier part of this video. I was like, why is this working? Why isn't this working? You got to wait till it converge. RIP is so slow. That's why I'm just like, I have yet to touch a net. I work for a managed services provider. It's a Fortune 500 company. We touch more than 400 networks. I have yet to see a RIP. I'm really getting frustrated with this study in here. I have yet to touch RIP networks or see an RIP network. It is such a slow routing protocol. It's so old, but y'all see, I was sitting here configured like, why is this not working? It took 30 seconds for the network to be converged. That is the reason why we have to wait a short period of time before we should verify connectivity. But anyways, I almost had a roid raise right there. On router 1, display information about the active protocols on the router. Is router 1 now sending and receiving version 2 updates? So we'll go to router 1. How do we see what kind of protocols he's running? Simple. Show. Oh, you know, I should have done some debug commands. Let's do some debug commands real quick. The debug IP rip. Now we're debugging RIP commands, right? And while that's going, let's do a show IP protocols. Says here, sending updates every 30 seconds, which is why, like I said, it takes a while for a network to converge. You know, that would not fly in today's world. 30 seconds for the network to go down it seems like an eternity. Anyways, there goes some debug commands for y'all right here. Look, we had to wait 30 seconds. Well, not 30 seconds. It took a little bit, but we got these. Here goes some debug commands for RIP. We got received an update from here. It told us about this network. We got some some metrics. It told us how many hops to get there. Basically what you see in the routing protocol. Also, what was the other question? Is router 1 now sending and receiving version 2 updates? We did a show IP protocols, and version 2 is listed. There go another update right there. Show IP protocols, right? Just think about it. When the network goes down, try it if you're a network engineer, or try it at your house. Just unplug the network and your modem and see how long it takes before everybody in the house, depending on how many people you have in the house, to be like, hey, what's going on with the internet? You see how long it'll take before people start doing that. We are, yes, sending version 2. I'll do that again. These debugs are getting annoying. Send version 2, receive version 2. So yes, we are sending and receiving version 2. Anyways, that's enough of my roid rage, my rant of the RIP routing protocol. We still have to learn about it for some reason. If you are a network engineer or a network technician, or you are in the IT field and you are God forbid you are working a network that supports, or not just supports, it's running RIP routing protocol, please comment below. Let me know. Send me a Twitter. Here go my contact information, y'all. That's my contact information. That's my YouTube. That's my Twitter. Let me know if you know any networks. You ain't got to shout them out or snitch on them like that. But let me know if you still touch networks that are using RIP. For now, comment, like, subscribe to the network, bruh.